Hey students, today we're going to be talking about climate control factors. Let's just do a quick review. Climate is the long-term average of precipitation and temperature for an area. And when we talk about long-term, we're not talking about a couple of years. We're talking about many years, 10, 20, and lots of people use 30-year averages as their benchmark for what constitutes climate for an area. So weather is individual day-by-day events that changes frequently, especially in Colorado here, and climate is a long-term average of what's going on. And there are a lot of factors that affect the climate for an area. We're going to focus on 7 of those factors. And now we're going to focus on big picture stuff, and there's a whole lot of little other things that can influence the climate of an area, but we're just going to focus on some key ones. And so the first one we want to talk about is latitude. When we talk about latitude, we're talking about how far from the equator are we. And so if you see on my map over here, 0 degrees is where the equator is at. Okay, so that's in this area here, and then 90 degrees of the poles. And the farther we get north or south, we definitely get some different activity going on in terms of climate. So how does our distance north or south of the equator, how does that affect precipitation, and how does it affect temperature? Well, let's talk about temperature first. So if you see my picture here, if we're close to the equator in this area, the sun's rays are spread over a very small area. We talked about this when we talked about seasons. And so you get a larger concentration of sunlight in a smaller area compared to closer to the poles or farther from the equator, also known as higher latitudes. That sun is getting spread out over a larger area because of the curvature of the Earth, which means that a particular area north or south of the equator is going to have less sun concentrated. How does that affect temperatures? Well, easy connection. The higher concentration of sunlight in an area, the warmer the temperatures are going to be. So the farther we get from the poles, north or south, the colder our temperatures are typically going to be. Now, this also has an impact because of seasons, right? So not only do we get colder as we move away from the equator, also during our summertime, the farther we are from the equator, the warmer we're going to be. And in the wintertime, the farther we are from the equator, the colder we're going to be. And so remember when we talked about seasons, those temperature extremes are greater. If we were here closer to the equator, we don't get as much of a temperature change from winter to summer into winter. If we're up here closer to the poles, or where we are in Colorado at about 40 degrees latitude, we definitely get some big temperature differences between the summertime and the wintertime. So the farther we are from the equator, the colder it's going to be in general. The farther we are from the equator, the bigger the temperature fluctuations are going to be between winter and summer. So let's talk about precipitation now. We'll pull out this map here. And if you remember when we talked about our global winds and the Coriolis effect and all of that, we have these very large belts of high pressure and low pressure around the globe because of the massive convection currents that happen due to the differential heating of the Earth, which again goes back to our sun ray stuff. Now, if we look at this map here, we see that, remember, we have lots of warm, moist, rising air at the equator. And that usually, those low pressure systems, those equatorial lows, create lots of precipitation. And so we get lots of rainforests in these areas because of that. So if you're around the equator, you're going to get a lot more precipitation. Also, here where we have another low pressure system, go away. Here where we have another low pressure system, here and here, all right, those we get more and more precipitation there where we have that air rising, condensing at those polar fronts and dropping a lot of moisture. However, if you sit around the 30 degrees north and south or up towards or down towards the poles, those areas are high pressure systems, and so we see a lot of dry weather there. We see very low amounts of precipitation. So if you're trying to predict the climate for an area, you really need to look at what are the global wind patterns doing in that area in terms of high and low pressure systems. Okay, so latitude definitely has a really big impact on climate, both temperature and precipitation. Let's go ahead and go on. to our next climate factor, which is elevation. Now, elevation, if you remember when we talked about atmospheric pressure, as we go up in elevation or altitude, the pressure goes down. That means there's less air. And so as we rise up, because there's less air, the temperature actually goes down. So how does elevation affect temperature? The higher in elevation we are, the colder the temperatures are. And there's actually a formula that we can use to calculate that. We're not going to do that here, but we can see if you're at sea level, you might have 30 degrees Celsius, but if you get up to 2,000 meters, now you're looking at colder temperatures there. Now, we're not all living on the edges of mountains, but if we look at the map of the US here and we compare some elevations, this shows us the elevation differences in the United States. So down here along the East Coast in the Gulf, we have close to sea level, so we're not very much above 500 feet in elevation. If we move out to kind of the central plains in here, the Midwest, we're getting higher in elevation, and that's going to zoom in again. Stop doing that. And then if we get over here to Colorado, look at our elevation in this area, right? We're in the you guys know we're at the Mile High City, so in the 5,000 feet range. So as we go inland in the United States and come more towards the central plateau here, with elevation increases and temperatures go down. So the higher you are in elevation, typically the colder the temperatures are going to be compared to an area that's at a lower elevation. How does elevation affect precipitation? Well, we're not going to get into that too much, but if you're a higher elevation, of course, you're more likely to see snow. And in a few minutes, we'll talk about the Rainshadow Effect, where if you're at higher elevations on the windward side of a mountain, you're going to see more precipitation. But for now, if you're taking notes, just know that as you increase in elevation, temperature gets colder. So higher elevation, colder. Okay. Next, we're going to talk about our third climate control factor here, which is proximity, or how close you are to a body of water. And we're going to use San Francisco for our example here because it's really emphasizes how being close to the ocean or very big lakes can affect your temperatures. Let's focus on temperature first. What do we know about large bodies of water and sunlight? Here, if we are looking at a large body of water, this is where San Francisco is there, that as the sun energy is coming in, that body of water is able to absorb a lot of that energy that's coming in, but it doesn't change temperature very much. Likewise, during colder times, that large body of water is able to distribute some of that heat, a lot of heat, to that area. The effect this has is a moderating effect on temperature. So let's look at the climatograph or the temperature graph here for San Fran. Look at it in the wintertime. Now, keep in mind the latitude of San Francisco is not a whole lot different from where we are in Colorado. I mean, I'm not sure exactly what it is, but it's probably 5 degrees difference, so it's not very much different. But look at the coldest temperatures, average temperatures. I got to turn that thing off. The coldest temperatures in the wintertime, February, December, are in the 40s. Think about our coldest temperatures. You know, they're in the 20s, 30s, quite a bit colder in Colorado. But look at their high temperatures in that time. The high temperatures are in the 50s. So there's really there's not a huge temperature difference between the lows and the highs during that time. That's because that large body of water is absorbing and releasing that heat energy. Also, from summer to winter, in the summertime, our temperatures are in the 70s during the day and in the 50s at night. So there's not a huge difference in temperature here during the day and night because the water is regulating that temperature. And our summer temperatures and winter temperatures are not that different from each other. Again, because that large body of water is absorbing and releasing heat, and it has a moderating effect on the environment around there. Now, the wind patterns in this area have a really important factor to play in all of this, and we'll get into that in just a little bit. Another thing we could talk about in terms of being near a body of water, of course, is precipitation. So how does being close to an ocean or a large lake affect precipitation? Well, you can imagine if you're close to a lot of water, you're going to get evaporation from that water. And if the winds are right, and in the case of the western United States, our winds are from the west, right? So they're pushing a lot of this moisture from the Pacific Ocean over to California and some of those areas there. Again, there's a lot of other factors here. So if you're going, well, there's some deserts in that area, you're right. There's a whole lot of other factors that are playing in here. But in general, if you're near a body of water, you're likely to have more precipitation because you have that large amount of moisture that can be input into the air. Wind patterns are a really important part of this, so we'll talk about that in just a second. Okay, let's look at our next climate control factor. And that's going to be ocean currents. So again, being near a body of water definitely has an influence on our temperature and precipitation. By now you should have learned that our ocean has lots of currents going on, and these currents move in the northern hemisphere. So let me draw my equator. It's pretty close. In the northern hemisphere, because of the winds blow to the west here and to the east here, and we get these gyres that are set up. So we get these counterclockwise, in the northern hemisphere, we get these clockwise currents that are these gyres that are spinning in the ocean. And in the southern hemisphere, because of the wind patterns, these surface currents are moving in a counterclockwise direction. Anyway, what we see here with these currents is they can carry cold and warm water to higher or lower latitudes. So a really good example of this is the Gulf Stream. So let's take a look at this picture here. The Gulf Stream carries water from the equatorial regions down in here, and it brings it up along the coast of the United States. And some of that water actually makes it, because of the currents, it makes it over to the European peninsula over here. Now, what does that do to the climate? It actually has a warming effect, because you're taking warm water and you're pushing it up to the north where it's typically colder. And the energy from these currents actually has a warming effect on this region here. The same can be said with colder currents, and so if you're looking at a cold water current, that could have a cooling effect on a region. Again, the wind patterns are really important here. Just like with warm and moist air masses, the currents that are warming or cooling air off in a region are going to have a major impact, or have more or less of an impact depending on which direction the winds are coming from. Now, we have westerly winds here, and so those winds are pushing this nice warm water that's warming the air above it this direction towards Europe and causing a warming effect. So so colder currents can have in terms of temperature, can cool off an area. Warmer currents can warm up an area, but it really does depend a lot on which direction the winds are coming from as well. How do these affect precipitation? Well, we're not going to focus a whole lot on that, but just know that if you have a warm current and warmer water, you're likely to get more evaporation. And so in this area, we're going to see more evaporation and more rain and precipitation because of the warmth of that particular region. If we have colder water, we just get less evaporation, and so that could have an impact on the amount of precipitation that falls. So really the main part that is affected by climate in terms of how do currents affect climate is temperature changes, but precipitation can be a small part of that as well. Okay. So like I've been saying, the direction of the wind has a major influence on climate. And so let's go back to our currents and our bodies of water. And let's look back up here at the west coast of the United States. All of the winds that are hitting the west coast are coming from that westerly direction. And so we have to look over, like, what's actually over here that's going to affect the climate as those winds push those air masses towards the continental United States. Well, we have an ocean, and so there's because there's going to be a lot of evaporation and moisture, we can expect that we're going to get higher amounts of precipitation because of those prevailing winds. But if you look at where we are in Colorado here, Where is our wind coming from? It's coming across the United States. It's already dropped a lot of its moisture because of the rain shadow effect, which we'll look at in just a second. And so we're likely to actually have less precipitation because we are sort of an inland. We're not close to a body of water. And those winds are pushing that air mass across the United States, and it's losing a lot of that precipitation before it gets to us. Now, the other thing is, if you're, like we mentioned, if the wind is pushing air masses across from an ocean over to the land, that's going to have a moderating effect on temperature. But if you are here in the central United States and that air is blowing from the west and coming across the land, you're going to have much greater temperature extremes, because remember, whereas water has a moderating effect on temperature, it keeps it from changing much. Land has a much lower specific heat, and so you're going to get much bigger temperature fluctuations if you're inland than if you're by the coast. This really ties in again to currents and being near a body of water, but that all connects to winds as well. So if you're inland, you're going to experience bigger, hotter temperatures during the day, colder temperatures during the night, hotter temperatures in the summer, colder temperatures in the winter, because that air mass is moving across land instead of water before it gets to us. Okay, so that helps us understand a little bit again of how our prevailing winds have an impact on temperature and precipitation in different areas. Let's look at topography. Now, topography is just a fancy name for are there mountains, or is it flat, or are there hills? You know, the lay of the land. What does it look like? I've put a precipitation. Let's talk precipitation here and not as much temperature. So for precipitation, here's Colorado, an average precipitation for Colorado from 1961 to 1990. It's an average. And so again, this is climate, right? Because we're looking at an average over a long period of time, like a 40-year period. Sorry, a 30-year period, if I can do math there. And so here, this is all about climate. Let's look at what we see here. If we look at this area here, I can't do circles, it'll do that zoom in thing. We get less precipitation, so 10 to 15 inches in this area. This would be the Front Range and the eastern plains of Colorado. But if you look up here, okay, we get quite a bit more precipitation, 25 to 30, some places 40 inches of precipitation. So what's going on in Colorado that's causing so much precipitation on the west side, and it's so dry over here on the east side? This is called the Rainshadow Effect. It's a really important feature, climate control feature. And so anytime we have a large presence of mountains or very uplifted area, so your Rocky Mountains, your Appalachians, they're smaller, but they still have an impact. All of your major mountain ranges are going to experience this, what we call the rain shadow effect. So here's how it works. Now, this is not to scale because we've got a whole nother mountain range over here from the Rocky Mountains to the Pacific Ocean. But if you think about where's our wind coming from, we've got these prevailing winds, and they're pushing warm, moist air from the ocean, from the east, from the west to the east. Well, if it's flat, then that air is just going to cruise along. But what if there's a mountain range like this? That's going to cause that moist air to get pushed up. It's going to have a lifting effect on the air. It's got to go up because it can't go through the mountains. As it gets pushed up, that air cools and it condenses. And you guys know that condensation is what eventually leads to precipitation. So we're going to see a lot of precipitation happening on what we call the windward side of the mountains. That's the side that the wind is actually coming from, or it's hitting the windward side of the mountains. So what do we see there? We see a lot of vegetation with all that precipitation. We see really deep snow. And of course, this is why we have such great ski resorts in Colorado, is that rain shadow effect drops a ton of snow on those mountains that are more towards the west slope. All right. Now, what impact does that have for us? As that air drops its moisture and then drops down on the other side of the mountains, it's pretty dry. It's dropped a lot of its moisture on the windward side. This is called the leeward side. So the lee side is the side that's is like where the wind is going to. It's the opposite side of the windward side. And what do we get here? We get what's called the rain shadow. And that's where we have very little precipitation. It's very dry. Okay, so, oops, dry. Going back to this map, that explains why we have dry areas over here on the eastern plains. We have this large mountain range, our Rocky Mountains, and they are having that impact of pushing the air up, causing the air to go up, and then dropping a lot of its moisture. And that creates a rain shadow over here where it's dry. I'm having trouble spelling that. That's dry over there. So when we talk about topography, that's really the rain shadow effect is the main thing that we want to focus on. And anywhere that you have a mountain range, you have to consider where are the winds coming from and where are they going to. And if you're on the windward side, you're going to have more precipitation than if you're on the back side, the leeward side, that is dropping that dry air around. Okay. Now, the last thing, which we're not going to get into a whole lot, is the type of vegetation in an area. Just think about temperature-wise. I've got three areas here. I've got a desert, I've got grassland, and I've got forested area. Here's the key thing. The more vegetation you have in an area, the less temperature fluctuations you're going to have. Why is that? Remember, the specific heat of sand is less than 1, and then plants have a specific heat of, we're just going to say, an average of 2. So really, plant material heats up twice as slowly, if you want to think about it that way, as sand and other materials like dirt that are found in open areas without vegetation. So vegetation has a moderating effect, a small moderating effect on temperature. It means that if you're in an area that has a lot of vegetation, you're going to get not as much of temperature swings during the day and the night. But a forested area has a much bigger impact on that than like a grassland does. So we're going to see less temperature extremes in our forested area here, and then we're going to see more temperature extremes in our desert, and then we're going to see kind of middle temperature extremes in our grassland area. What about precipitation? By now you should know that plants do what we call evapotranspiration, where as they're doing their photosynthesis, water is moving out of their stomates and it's going up into the atmosphere, and that water can eventually create clouds. That moisture can create clouds and then precipitation. And so typically, if we're in especially a heavily forested area, we're going to see more precipitation in those areas because of the evapotranspiration that's going on. All right. Now let's make some comparisons. If you want to navigate to the website that I'm using here, which is McDougall-Littell, and it's all about climate zones. And they've got a tutorial here that kind of helps us compare some climate for different regions. So here's what we want to do here. We want to compare two different cities, and we want to try to make get some reasons why we see some differences between these cities. So we're going to start with Flagstaff, Arizona and Phoenix, Arizona. On our climatograph up here, we want to look at these two different comparisons, and then we'll also look at the graphs that are down here. Okay. Now, one thing we want to look at is latitude. So what's our latitude like? 33 and 35, they're very similar, so that's not going to be a major factor here. This also tells us our elevation, and if we notice, our elevation for Flagstaff is 7,000 feet. Our elevation for Phoenix is only 1,100 feet, so there's quite a big difference in elevation here. But let's look at temperature and precipitation, because that's really what we care about, and we want to use the differences in temperature and precipitation and try to use the climate controls to explain why those are different. So what do we see? In Flagstaff, I want to look at my graph down here. I want to look at this line. So this is our maximum temperatures. In the summertime, our maximum temperatures are in the 80s. In the wintertime, our maximum temperatures are in the 40s. And those are the averages. Oh darn, it's going to do that thing again. Those are averages, okay, 40 to 80. Look at our minimum temperatures here. Our minimums are 50 and about 15 here between summer and winter time. If we go over to Phoenix and we look here, our maximum temperatures in the summer are in the hundreds, right? And that's hot. And our minimum temperature or maximum temperatures in the winter are in the 60s. In the wintertime, we see 40s for the winter and high 70s for the summertime. So what's a big difference in temperature we see here? In general, Phoenix is hotter than Flagstaff. All right, so Phoenix is hotter. The temperature differences are not that extreme. They're pretty similar to each other. Let's look at precipitation here. So the mean precipitation in Flagstaff, that's just average precip, is about 23 inches, whereas only 7 inches in Phoenix. So what's going on there? Well, let's try to analyze the difference in temperature and precipitation. Let's talk about temperature first. What do you think is the main reason why Flagstaff is cooler than Phoenix? Well, if you said elevation, you're right. So remember, as we go up in elevation, our temperature is going to get cooler. So simply because Flagstaff is up quite a bit higher than Phoenix, it's going to be colder. Are there any other issues here? I mean, they're both in the same proximity to water. We don't see a regulating effect there. So really the biggest temperature difference, the reason for that is going to be the elevation difference. What about in terms of precipitation? Well, Flagstaff is kind of set up on the mountains. It's up higher, and so we're going to get a little bit of a rain shadow effect. And remember, if we look at those westerly winds that are coming across, all right, Flagstaff is at a higher elevation, so it's more likely to get some of that rain shadow effect and drop some of the precipitation on that higher elevation than Phoenix. So elevation again is a big part of that, but also the topography would have an impact on precipitation there. So again, we're comparing these cities' climates and we're trying to figure out why, based on these climate control features, why would they be different from each other? Let's look at another one, and there could be others here that you notice. So if I don't mention one, that doesn't mean it's not a factor. So let's now compare North Bend, Oregon and Boston, Massachusetts. Okay, they're across the country from each other. Let's look at temperatures. I want you to notice how flat this line is from winter to summer back to winter for the high and low temperatures for Bend, Oregon. There's not a huge difference between summer and winter. Okay, but if we look at Boston, we're down in the 40s here for the highs in this winter and in the 80s for the summer. In the minimums, again, we have a big difference here. We have 20 to 60s. And so there's a much bigger temperature extreme here between Boston and Bend. So we want to see what would account for that. The other thing we see is for precipitation. So North Bend is 63 inches and Boston is about 20 inches less than that, about 42-ish inches on average. And most of that, if you look here, falls as snow for Boston. So let's talk temperature. Why would the temperature be so different between Boston and North Bend? Well, look at where North Bend is, right? It's over here on the Pacific Ocean. Remember that our prevailing winds push wind this direction. So where is that wind coming from? It's coming from the ocean. It's going to have a moderating effect on that climate. It's not going to have too much of a temperature extreme. And that's why we see these lines are pretty flat. We don't have really big temperature swings between the seasons because this is a maritime climate. It's close to an ocean. Look at Boston though. Where is its wind coming from? Also from the west, right? Because they're at the same latitude here. But the air that's moving across the land here is heated and cooled a lot differently than the ocean air. And so we see much bigger temperature extremes from the winter to the summer, both highs and lows in Boston. That's because of those prevailing winds, and where they're coming from is bringing colder or warmer air across the continental United States. Again, there's a whole lot of other factors here. So if you know some more stuff about the jet stream and how it curves down and whatnot, that's good. But we're only hitting certain pieces of information here. Well, what about the precipitation part of this? Well, they're both near a body of water, but again, this has to do with the direction of our winds. The winds here are pushing warm, or at least moist, it may not be super warm because you got cold currents over there, warm air to North Bend, moist air to Bend. Also, if you know anything about Oregon and Washington, there is a mountain range right through here. So topography is a feature of this because we're going to get more moisture dropped in this area, and it's going to be dry over here. If you've ever been to Bend, Oregon, it's pretty dry. Over here on the coast of Oregon, it's pretty wet. And the same thing with Washington. That mountain range this year has really affect the amount of precipitation there. With Boston, why does it get less precipitation? Well, again, you've got colder, drier air that's moving across the continental United States, and that's where the air for Massachusetts is coming from. So you have two main features here. The prevailing winds are pushing moist air towards North Bend, and that mountain range is causing a high amount of precipitation because of the rain shadow. Whereas Boston is getting drier air coming from the continental air masses. Those prevailing winds are pushing drier air towards it, so it's not going to get precipitation, and there's also no mountain range to cause that rain shadow effect. Again, latitude is not a factor here because they're at the pretty much the same latitude. Elevation-wise, they're pretty much at the same elevation. North Bend's at 10 feet and Boston's at 30 feet, so that's not enough of a factor to really worry about. Okay, let's make our last city comparison here. So we've got Dallas, Texas, and Fargo, North Dakota. Already you should just notice the difference in latitude here. That's going to be a major factor, right? We're going to see warmer temperatures in Dallas because it's closer to the equator. We're also going to see less seasonal changes in Dallas. We're not going to get real cold winters and real hot summers. It's going to be less of a temperature difference. And we see that this line is a little flatter compared to this line for Fargo between summer and winter. But in Fargo, we're going to get colder temperatures in general because we're farther from the equator. In the summertime and the wintertime, we're going to get more temperature extremes because of those seasonal changes and being farther away from the equator. Also, in terms of precipitation, Dallas gets about 33 inches, Fargo only 19. Why would that be? Well, Dallas is closer to a body of water. Right, Fargo is about as landlocked as you can get, and all of the air that's coming towards Fargo is coming from the west over the continental United States, and it's pretty dry air in general, and so it's not getting as much precipitation as being close to a body of water. Any other factors that would influence temperature precipitation for those two? The proximity to the body of water and the latitude are really the two key features here for these two cities. Lastly, let's talk about Colorado real quick. What's our climate like? First of all, we're pretty dry, right? We have that rain shadow effect that we already talked about that influences the Front Range and the Eastern Plains, and it makes us pretty dry. The west slope is a little bit more green. It's got some more precipitation on that side. But in general, we're pretty dry. Why is that? That's because we're in the middle of the continental United States and we're far from a body of water. So that's going to lead us to less precipitation in general. Also, we're going to get pretty big temperature extremes. And so if we look at our maximum temperature averages and then our minimum temperature averages, this is for Fort Collins, so this is not statewide, but we get a pretty big temperature swing from minimum to maximum because we're inland and because we're not near a body of water. We're going to get hotter temperatures during the day, colder temperatures at night. Also, in the wintertime, we have colder temperatures than we do in the summertime, right? This is a pretty big curve between winter and summer. Why is that? That's because we're inland, we're not near a body of water, and so we're going to have bigger temperature extremes. Also, our latitude has a major impact. We are close to that 30-degree line, not too far from that, and so we're close to some of the high pressure regions on those global wind belts, which is one of the reasons why we have fair weather a lot in Colorado, because of that high pressure. That does depend on the time of year because those belts move around between summer and winter, but also since we're inland, since we're farther from the equator, we're a good distance from the equator, we are going to get bigger temperature extremes from winter to summertime in terms of temperature changes. So Colorado, relatively dry, big temperature swings because we're inland, and those are some of our main factors. And then of course the rain shadow effect has a major impact on the kind of the microclimate between the west side and the east side of the United States. So I hope this helped you learn a little bit more about the climate control features, and that we could now, I hope you can use those to really compare different locations and have a better understanding of why the climate is different from location to location. You'll need to apply this in our assignment that we'll do, where you'll be predicting the climate of different areas based on the information you're given. Thanks for listening. Have a good day.